Hello and welcome to today's session on corporate risk management techniques. I am Dr. Maruf Ahmed Mir, PhD in financial markets and MBA in finance and accounts from AMU Aligarh. And at present, I am associated with Asian Business School, Noida as associate professor in the area of finance and accounts. Dear students, let's start with the introduction to corporate risk management techniques. The management of risk is currently one of the main areas of interest for researchers and practitioners working in a wide range of projects because of the benefits of the process. Risk management is one of the key project management processes. Numerous techniques are available to support the various levels of the risk management process. Risk management is a tool which is increasingly used in the organizations and by public bodies to increase safety and reliability and to minimize losses. It involves the identification, evaluation and control of risks. Implicit in the process is the need of sound decision making on the nature of the potential socio-technical systems and their predicted reliability. The need of the safety measures and guidance as to where they should be displayed are, in theory, the natural products of combined probabilistic risk assessment human reliability analysis called as PRA or HRA studies. In an ideal world, good assessment should always drive effective error reduction. Now we will discuss and describe the tools and techniques used in the assessment of risk, both qualitative and quantitative techniques. French and Sword 1983 describe a tool as any device or instrument, either manual or mechanical, which is used to perform work. Distinguishing between a tool and a technique is difficult. For this purpose, in his book, the present author defines tools. For example, risk management tool employs numerous techniques such as sensitivity analysis, probability analysis, and decision trees. Value management tool employs such techniques as functional analysis, option engineering, and criteria weighing. Now we discuss risk analysis techniques. There are two main categories of risk analysis techniques, the qualitative and the quantitative. Qualitative methods seek to compare the relative significance of risks facing a project in terms of the effect of their occurrence on the project outcomes. Simon et al. 1997 suggests that the information obtained from the qualitative analysis is nearly always more value than that from the quantitative analysis, and that the latter is not always necessary. Thompson and Perry 1992 recommend qualitative analysis for developing an initial risk assessment. Quantitative techniques attempt to determine the absolute value ranges together with probability distribution for the business or project outcome, and consequently involve more sophisticated analysis, often aided by the use of computers. According to Simon et al. 1997, to achieve this, a model is created of the project under consideration. It is then modified to quantify the impact of specific risks determined by an initial assessment using qualitative techniques. The model will include all the elements which are relevant to the risk analysis, and against these elements, uncertain variables can be entered rather than the fixed values to reflect areas of significant uncertainty. What decides the choice of techniques? According to Norris 1992 and Simon et al. 1997, in determining which of the available analysis technique is most suitable for application to a particular investment, management should consider the following: the availability of resources for analysis, humans, computational, and time. Next, the experience of the analysts with different techniques. Next is the size and the complexity of the project, the project phase in which the analysis takes place, the available information, the purpose of the analysis. In any analysis or assessment where data are required, then the data should be considered as follows. Number one, accuracy. Are data accurate? Adequacy. Are they adequate for the purpose of the project? Relevancy. Are they relevant to the subject? Coherence. Has the information been classified in an orderly and a meaningful way? Impartiality. Has the analyst remained unbiased? Direction. Does the analytical procedure lead to conclusions and decisions? Logicality. Is the reasoning sound? Validity. Are comparisons, interpretations, and implications valid? Now let's study the qualitative techniques in risk management. The first technique is brainstorming. Originating in Madison Avenue in 1950s, brainstorming was long considered the preserve of those wild and wacky folk in advertising. In more recent years, however, it has spread into the mainstream and is now used by businesses of all kinds, not to mention the civil servants, engineers, project managers, and scientists, or indeed anyone with a problem to solve. The optimum size for a brainstorming session is 12 people, and the ideal length of time is between 15 and 45 minutes. Though session can last all day, refer to Sunday Times 2001. The basic rule can be summarized as imposition of a time limit, a clear statement of the problem at hand, a method of capturing the ideas such as the flip chart, somewhere visible to leave the ideas and let them incubate, adoption of the principle that no idea is a bad idea, suspension of the judgment, encouragement of a participant to let go of their normal inhibitions and let themselves dream and drift around the problem, encouraging quantity rather than the quality. Evaluation can come later. Cross-fertilization by picking up the group ideas and developing them. Chapman in 1998 stated that the brainstorming process, borrowed from business management and not specifically created for risk management, involves redefining the problem, generating ideas, finding possible solutions, developing selected feasible solutions, and conducting evaluation. However, Bauman and Ash 1987 believe there is a tendency of group to make riskier decisions than individuals because the factors such as dispersed responsibility, where influential members of the group have more extreme views and moderate members remain silent. Number two, assumption analysis. Assumption analysis is an intuitive technique and is where assumptions typically made in project planning are identified. These are then assessed as to what impact their proving false will have on the project outcome. Assumptions to which the outcome is seen to be sensitive and which have a likelihood of proving false will form the basis of a list of risks given by Simon et al. 1997. However, there is a danger that not all assumptions will be identified since a large number of them will be implicit. The next technique, third one, is Delphi technique. This is a technique for predicting a future event or an outcome in which a group of experts are asked to make their forecasts initially independently and subsequently by consensus in order to discard any extreme view. In some circumstances, subjective probabilities can be assigned to the possible future outcomes in order to arrive at a conclusion. Delphi is an intuitive technique and was developed by Rand Corporation for technical forecasting. Myrna 2002 stated that the technique involves obtaining group consensus by the following process. The respondents are asked to give their opinion on the risk pertaining to a project or an investment. A chairperson then collates the information and issues a summary of the findings to the respondents, requesting that they revise their opinion light to the group's collective opinion. These steps are then repeated until either consensus is reached or the chairperson feels that no benefit will result from further repetitions. The respondents are isolated from one another to avoid conflict and interact only with the chairperson. The Delphi process tends to take place through either the postal service or electronic interactive media. Chapman in 1998 cites that benefits from the Delphi technique include that participants are free from group pressures and pressures of conformity, personality characteristics, and compatibility are avoided. The fourth technique is interviews. This intuitive technique is used where information requirements need to be more detailed than a group can provide, or where group work is impractical. Interviews provide a means of soliciting information from individuals. Often corporate level personnel will request interviews with project personnel to elicit the information regarding the potential risk at the project level, which may affect the commercial viability of the project and thus affect the financial stability of the SBU undertaking it. Another fifth technique is hazard and operability studies, which is called as HAZOOP. HAZOOP is an inductive technique and was developed by Imperial Chemicals Limited for the risk identification in chemical process plants. It is a type of structured brainstorming whereby a group systematically examines the elements of a process and define the intention of each, developed by Ansel and Wharton 1995. Frostick 1997 cites guide words such as not more or less to be used to identify possible deviations from the intention. Such deviations can then be investigated to eliminate their cause as far as possible and minimize the impact of their consequences. The HAZOOP approach is flexible and can be used to identify potential hazards in facilities of all kinds at all stages of their design and development. Alternatively, a review of contingency plans at an existing facility could be more comprehensively informed by a HAZOOP exercise, which could identify hazard not previously planned for. Number 6 technique is failure modes and effective critical analysis, called as FMECA. The FMECA is an inductive technique and undertaken by a single analyst with a thorough knowledge of the system under investigation. This technique may focus either on the hardware involved with a concentration on potential equipment failure or on event with an emphasis on the outputs and the effect of their failure on the system. Every component of the system is considered and each mode of failure identified. The effect of such failure on the overall system are then determined. This was developed by Frostick 1997, Ansel and Wharton 1995. This technique uses a type of weighted score to identify areas of project most of the risk of failure. In a routine situation, FMECA is generally used at strategic business and project levels. It highlights areas of concern and is effectively points resources towards the perceived problem areas. The technique is often used for auditing company, hardware company, computer-based and equipment. Another technique, the seventh technique, is checklists. Checklists are deductive techniques derived from the risk encountered previously and provide a convenient means for management to rapidly identify possible risks. They take the form of either a series of questionnaire or a list of topics to be considered. Organizations may generate checklists for themselves or make use of standard checklists available for the particular industry or sector. Another technique, eighth technique, is prompt lists. These are deductive techniques and classify risk into types and area groups. For example, financial, technical and environmental, or the task group with which they are associated, for example, design, construction and commissioning. They may be general, industry or project specific. Ninth technique is risk register. A risk register is a document or database which records each risk pertaining to a project or particular investment or asset. As an identification aid, risk register from previous similar projects may be used in much the same way as checklist. The risk register enables data collected during the risk management identification process to be captured and saved for review and a data container for information on the choice of risk software. Their area number of prerequisites, data items necessary within the risk register are as follows. First, the title of the project. This should be briefly describe the project. Number two is the project ID. This allows identification of specific project where multiple projects are being developed. Another is the activity ID. Next should be the activity acronym. Another one is the team leader's name and the names of the individual teams. This information is necessary should any further investigation be needed or any query in regard to the original risk assessment be raised. Activities. This column is a list of activity description, preferably in order of sequence. The register may be used for network or spreadsheet models. Procedure. This is important for network-based risk software packages. It identifies the linkage between the activities from start to finish. Most likely estimated by the experts for the activities, this is a value used in the risk software package around which the optimistic and pessimistic value operates. This is commonly referred to as 3-point estimate. Risk measure charts can be developed from the risk register. The goal of a risk measure chart is not to solve the risk, but to assign tasks to the responsible party. For example, scenario, change in government. Action, foster political neutrality, predict scope or contract changes by new officials. From these tasks, the responsible party can in turn perform risk analysis in further detail. The 10th technique is risk mapping. This involves the graphical representation of risks on a two-dimensional graph, where one axis relates to the potential severity of a risk eventuating and the other to the probability of it doing so. Risks are considered in turn and plotted on the graph. ISO risk curves drawn on the graph connecting equivalent risks with differing probability severity serve to guide the analysts in determining the relative importance of the risk which they plot. Al-Bahr and Crandall 1990. 11th technique is probability impact tables. Probability impact, called as PI tables, are used to assess the relative importance of the risks. As with the risk mapping, the probability of occurrence and the potential impact of a risk is determined by selecting from a range of flow, medium, high, For example, the numerical meaning of each of the scale points should be predetermined for the project and the investment. PI score are then derived for each risk by multiplying their probability score by their impact scores, allowing direct comparison of the risks. The higher the PI score, the greater the severity of the risks. Simon et al. 1997. 12th technique is risk matrix chart. The risk matrix chart is often used to segregate high impact risks from low impact risks. The risk matrix chart partly qualifies the probability and impact of a risk and is often used in risk management workshops where risks are identified and then assessed in terms of their impact and probability. For example, the risk of employees being late for the work would be classed as a kitten since little attention is needed because employees finish their work in their own time. Rain in Manchester is highly probable but has little impact on the construction work since operatives are trained to take specific measures to deal with such events. This would be classed as a puppy. Flooding of business premises could have a low probability due to its location, but should flooding occur, it would have a major impact on the business of profits. This alligators managed by ensuring that flood protection is in place or by storing finished goods in a watertight structure. In the drug development phase of pharmaceutical product, the side effect of first in man the tests are highly probable and may have a high impact. This stagger is often mitigated by keeping the tests down to a small sample and by ensuring volunteers are insured against long-term effects. Typically, the tigers and the alligators are mitigated before the puppy and the kittens. 13th technique. Project risk management road mapping. Each category of the road map is in the table present. Firstly, the simple techniques followed by a gradually increasing level of work and complexity. It is important to focus on the added value which is provided by the subsequent level when you are trying to identify the appropriate level for a particular situation. Many of such qualitative analysis methods are used at corporate and SBU level in the early stage of project definition when little detailed information is available. Now we will discuss the quantitative techniques in risk management. Quantitative techniques are used when the likelihood of the investor project achieving its objectives within time and budget is required, typically for budget authorization or presentation of the project status to the board of directors. It should be borne in mind that the output from quantitative analysis only as good as the input information. So adequate time should be allowed for its collection and validity. The first technique is decision trees. Management are often faced with multiple choices, which in turn are faced with many options. In many cases, management only have the resources to opt for one, which presents management with the problem of opportunity cost. However, deciding to adopt an option can be difficult and a useful technique to assess options is the decision tree. This technique explores various investment options available to the decision makers under risk and uncertainty, which are graphically represented in the form of sequential decisions and probability events. Merritt and Skites, 1983. PMBOK 1996 described decision trees as diagrams that depict key interaction between decisions and the associated chance events as they are understood by the decision maker. Decision trees show a sequence of interrelated decisions and the expected outcome under each possible set of circumstances, where probabilities and value of potential outcomes are known. They are used as method of quantification which aids the decision-making process. The aim of the decision tree is to produce an expected value for each option, which is the sum of the probabilities and their weighted values. The diagram begins with a decision node at the top of the sheet, and the subsequent chance events and decisions are drawn subsequently. As the decision making process proceeds from top to bottom, decisions are depicted as square nodes. These are linked by labeled straight lines or branches, which denote either decision actions if they stem from decision nodes or alternative outcomes if they stem from the chance event nodes. Hertz and Thomson 1983, 1984 and Gregory 1997. According to Thompson and Perry 1992, this technique can help clarify and communicate a sequence of choices and decisions. This technique has been used in industry to decide methods of construction, contractual problems and investment decisions. In theory, the technique could be used in any decision where there is an option or opportunity cost and a decision is needed. Second quantity technique is controlled interval and memory technique. The controlled interval and memory CIM model provides a mathematical means of combining probability distribution for individual risks. According to Simon et al. 1997, this technique has largely been superseded by simulation technique and is not widely used. That is all for today. Hope you have understood. So we will meet in the next episode with a new topic. Till then, take care and goodbye.